it from there. There we are. So could any of you confirm if you're seeing my screen right now? That is amazing. Thank you, Mariano. Okay, so this session is from Apex Newbie to Pro with apexsandbox.io. And what I'm really hoping to get is I'm really hoping to help people who are new to Apex get better at it. So first of all, thanks to our sponsors or to PDF Butler, Media Monks, GridMate. This is an amazing virtual conference and really thankful for these sponsors coming together. And of course, the Trailblazer community as well. I've worked with many different communities. I've worked with JavaScript, .NET before jumping into Salesforce, and I can tell you the Trailblazer community is just amazing. It's the most closely knit, best community I've personally. So thanks to the community as well. And who am I? My day job is Salesforce engineer. I work for Meta at the moment. I'm also a Pluralsight author. This is a platform for learning many different technologies. I have 3 courses on there on the Salesforce paths. And I really do think about teaching how to code while falling asleep. This is not a joke. I really do. This is something I'm deeply passionate about. And I have spent a lot of time just teaching people around me, just seeing how we can do better, how we can make people better at coding. And I'm specifically excited about this conference because I'm from Pakistan myself and just excited to be a part of it. So what is the agenda today? The short story is we want to see how we can become great at coding. What I want to do is I want to present tips and advice to get better. A lot of this advice is going to be backed by research. A lot of this advice is going to be backed with my personal experience as well. And we'll also talk about what exactly you should learn. It can be overwhelming if you're trying to become a developer, not just Salesforce, but any kind of developer. So what are the different resources out there? What are the different technologies you should be learning? We'll talk a little bit about that. And finally, we'll also talk about practicing coding. Practice is essential to becoming better. This is true not just for coding, it's true for anything. Anything you're learning, practice makes you better and better. And we'll also talk about what's the correct way to practice and what to do if you're stuck. So I'll give a few seconds to let that settle in. I don't want to start with coding. I want to start with this microwave oven right here. So on the right on my screen, you can see a microwave without any lid. This is actually the touchscreen that I have for the microwave in my house. I'm going to demonstrate how I use this microwave to warm food, and I'd like you to pay some attention. This is not my example. This is an example I borrowed from an article online. It's called Learnable Programming by Brett Victor, and it's a great article. And let me show you how I use this microwave. I press this bottom button twice if I want to heat up some snacks. And this is another sequence I use to heat food that I take out of the refrigerator. And finally, here's another sequence. This is a sequence of buttons I press when I when I need to just make some popcorn. Just imagine trying to learn how to use a microwave using the examples I just gave you. You can imagine it's going to be a nightmare. It's just so difficult to learn how to use a microwave with just the examples I've given you. And unfortunately, sometimes this is what learning programming can feel like. And we don't want that. We want to move away from this. If you are ever feeling like this when you're learning how to code, then definitely watch on, and we'll talk a lot about why this happens and what we can do to fix this. And where we want to get is this. If you see this, then of course it's going to be far easier to make sense of those examples. This is where we want to get. This is how we become better at programming. Now, when I press this button, of course, it makes sense. If I press that start button twice, then my food's going to get heated for 30 seconds. If I press these buttons, that's 2 minutes 30 seconds. Then I press the start button. So of course that's going to work. Then press start. It's going to heat up popcorn, right? So when you see this, these examples make sense. And that brings us to the first tip for learning programming. And that tip is to focus on fundamentals. If you know exactly what each button does, that microwave isn't going to be very hard to use. But of course, if you feel like you're looking at the microwave without buttons, then we need to know what those buttons are. So you shouldn't face any mysteries when you're learning how to code or when you're looking at code. It shouldn't feel that there's things you just don't understand. If you look at a symbol or keyword and you don't know what it does, or you look at a line of code and you just can't explain what it does, or of course, if you feel like you're in that microwave situation, that means you're missing some fundamentals. And that's a sign that it's a good idea to probably step back and focus on the fundamentals. And I'm going to give you an example. I'm going to just show you sample code, which may appear difficult. I know a lot of you watching may be at different levels. For some of you, looking at this code is going to be very easy. It's going to make perfect sense. For some of you, it may, it may not make any sense at all. And that's okay, but just if you can read this code and understand a little bit of it, we create a new account A equal to new. We say a.industry equal to banking. Right, for that account, we set the industry to banking, and then we create another account B equal to A. Now this statement is key here, account B equal to A. We move on to the next one, B.industry equal to technology. So at this point, what is A.industry? If any of you have an answer, feel free to drop it in chat, but I'll tell you the key here is in understanding that statement number 3, account B equal to A. The answer is that A.industry is going to show up as technology. If I ran this code system.debug, it would print out technology. And that's because these kind of variables, objects, are copied by reference. If you don't understand that fundamental, you won't be able to understand this code. And here's another example. This is something that came up while I was chatting with somebody who was practicing on apexsandbox.io. These are two statements. If A is not equal to null and A.name is not equal to null. And the second statement is just the same thing flipped around. If A.name is not equal to null and A is not equal to null. So they are pretty much identical, but one of them works. And we see this in code all the time. If you're writing code as a developer, or if you're reading code as a developer, you will come across statements like this pretty much every day. And if you cannot tell which one is correct and which one is wrong, that means there is a fundamental that you're missing. And this is probably a point where you want to take a step back and focus on the fundamentals. Just to let you know what it is, it's something called short circuit evaluation. We don't need to talk about what it is, but just making the point that fundamentals are uh, extremely important. And we'll talk about how we can learn them. We don't have to learn them right now. So here's my second tip. And this one is backed very strongly by research. I went through a bunch of research papers before preparing for this presentation to see what they found as a key to learning how to code. And one of the things they all talk about is that it's very important to have a mental model of the computer that is running the code. Right, so I let that sink in a little bit. Whenever we look at a program, it's executing step by step, and it's incredibly important for a developer to know what the computer is doing as it reads each line. Oh, so there's a question here. Yeah, the answer was B. Let me go back to the last slide. A dot name is not equal to null and A is not equal to null. Which one of these is the correct one? So it's actually the first one. If A is not equal to null and A dot name is not equal to null. And that's because we want to avoid a null reference exception. A dot name is, yes, A dot name would throw a null reference exception if A is null. So we want to check A for null first. If A is not equal to null, only then we check A dot name is not equal to null. And the way compilers behave, sorry, compilers or interpreters, the way they behave is, this is an AND statement. If the first statement turns out false, it wouldn't even attempt to evaluate the second one. And that's why if A is null, it would never even attempt to evaluate A dot name. So this is why we always use the first example. Yes, thank you. Okay, so tip number 2, becoming the computer. So there's two things that are very important here. We need to understand how memory works, what the different data types are. When we declare a variable, what is the scope of the variable? When is it created? When is it destroyed? Which variables are considered reference variables or pointers, and which variables are considered values? Um, Coming last to an advanced point, why data structures such as hash set or hash map are needed. Now, I'm not going to explain what all of these things are in this presentation, but this is just an example of things that you should understand about memory. And you should be able to hand trace code. So this is, again, something I found as a very common theme in my personal experience as well, and research that has been done around programming as well. Being able to hand trace code is extremely important. When students learn to hand trace code, they immediately become better at programming. This means you should be able to take a code and just run it on a piece of paper to see what the output will be. So I personally just draw boxes for variables and just run the code line by line and see how the memory changes as the code runs. And this is where, if you're struggle to running code on a piece of paper, you want to ask for help or go back to the fundamentals, or ideally both. And you'll see me repeating that point a lot, returning to fundamentals. Programming is not very complicated, but unfortunately, I don't feel we have done, we programmers have done a terrific job of explaining the fundamentals, so you may often feel lost. And that is why it's totally okay to ask for help. Learning programming takes time, and you have to maybe sometimes look at different resources, do some experiments. It takes some resilience, but it doesn't mean that you are not doing something right. So if you don't understand fundamentals, just don't worry about constantly returning to them. I've been coding for, I think, well over a decade now, and I still sometimes have to come back to the fundamentals. So I'm going to give you an example of hand tracing code. So this is an example. This is a problem that I have on the website apexsandbox.io. And look at this code. It declares a Boolean variable b, then it declares an integer, age equal to 15. So at this point, b is empty. There's a variable called age, which has the value 15. And then we say b equal to age is greater than 12 and age is less than 20. So essentially, this is checking if the age is the age of a teenager, right? If it's greater than 12 and less than 20, that means it's somewhere between 13 and 19. So I'm going to show you how to hand trace this code. In order to hand trace, we need to understand what the precedence is. And just like arithmetic expressions, we evaluate one piece of it first. So the piece in red, age is greater than 12. That is the first thing that the interpreter or computer running the code is going to interpret. And what does that evaluate to? Age is greater than 12. So at this point in memory, the variable age is 15. And is it greater than 12? That's a simple. Yes, it is. So that means that part is going to evaluate. So what does the second part, what's going to be evaluated next? Next, the computer evaluates the second piece, that is age is less than 20. So is age less than 20? Yes, it is. The value of the variable is 15. And there you go, Mariano. So that's how this helps, right? That's how when you hand trace code, that's when you realize what exactly is going on. Age is less than 20. Yes, that is true. And finally, the next piece, what is the computer going to evaluate? We are left with true and true. True and true is simply going to evaluate to true. So once the statement has finished executing, the value true is going to go into the variable b. This was a simple example. For complex code, we can do exactly the same thing. And this is a powerful tool if you're trying to understand what code does, or if you're trying to see if your code is going to work. Just hand trace it. Running it on a piece of paper is generally a better idea than running it on a computer if you're learning. So how do you get better at these fundamentals? So there's a few resources that I personally really like. And I'm always on the lookout for resources. I want to put something together myself as well in the future. So definitely connect with me, follow, and I'll be sure to share when I do so. Java, A Beginner's Guide by Herbert Schill. That's a book that I learned programming from, to some extent, at least Java. That's the book I learned it from. And I think it did a very good job of explaining the fundamentals. It is Java. It is not Apex, but that's okay. These languages are just so similar that the foundations are exactly the same. If you look at a for loop written in Java or a for loop written in Apex, you pretty much can't even tell which language you're looking at. And then there's a course that I found online that's by Harvard X Intro to Computer Science. They call it CS50. It does an excellent job of explaining the fundamentals. This is something you can enroll in. It's completely free and it's offered by the best of the best. It's offered by Harvard. And then there's a course on Pluralsight as well, Apex Academy by David Lean. That's a course that I've personally found, that does a pretty good job of explaining the basics. And I've heard some really good feedback from people who have taken it as well. If you have other resources that you have used and you have found to be really helpful in explaining the basics, do share them with me and share them with the people on this call as well. Okay, so moving on, tip number 3. So this one is interesting. So I personally feel like if you are stuck, if you're saying that you know what, you can't really make progress, one thing you can do is, of course, go back to the fundamentals. Maybe pick up one of those books. Maybe take that course by Harvard. But it may not always be possible because if your day job, you're working as an admin, for example, you may not get those opportunities. Flow is programming. You're using pictures, you're using your mouse to drag and drop pictures onto the screen, but at the end of the day, you are writing procedural code. You're dragging and dropping an if statement. You're creating variables. You're using loops. You're writing sequential code. So if you master flow, you would notice that many of the concepts that you learn are going to translate into Apex. So this is why I personally recommend learning flow as well. People who have learned flow do come back and say uh, that they were able to translate those concepts to Apex. And not just the concepts of variables and if statements and loops, but also the concepts of before and after triggers. Right? If you're on the job and you don't get a chance to code, then definitely find opportunities to do some flows. Flow is, at the end of the day, programming, and it's definitely going to help you become a better programmer. And one more thing you would learn when when doing flows is flowcharts. So what are flowcharts? Flowcharts are, well, flow is actually based on flowcharts. Flowcharts are just a diagram representation of code. And when I was learning how to code, flow was not a thing, of course. I didn't even know Salesforce existed at the time. But flowcharts is something I used to draw a lot. And if I could not write code, the first thing I would do is draw a flowchart. And finally, with flow, you're learning the most important skill, and that is building solutions, trying to build a repeatable recipe for solving a problem. These things are the most important things to learn when programming. The syntax of a language is easy. So I strongly believe that if you learn flow, you're going to have an easier time learning how to code. And if you have any thoughts about this, if it has benefited someone, feel free to drop a message in the chat. And then tip number 4, take your time. Programming is something that doesn't happen immediately. You'll see progress in a few weeks, but it takes years to become good at it. And it's great. It's absolutely worth it. Even after years and years of coding, I'm still learning. And everybody who is a programmer is still learning. This is not news to any of you. If you've worked with Salesforce, you're working with Salesforce um, as part of your career. There is no stopping. There is something new to learn every day. And no matter how much you learn, you always find out that there's just so much more that you do not know and so much more that you can learn. And the same is true for programming as well. And for an example, like we have the 5-day development course that's offered by Salesforce. There's boot camps that I've seen that last a week, 2 weeks, 4 weeks. If you have taken them and come out feeling that you didn't really learn how to code, that is okay because these courses move way too fast. You have to move slow. You have to take the time. And just for an example, the course I'd mentioned earlier, the course by Harvard, or a computer science introductory course by any top school or any computer science degree, covers far, far less content than the 5-day development class that is offered by Salesforce. That class really targets experienced developers, not just people who are completely new to coding. So just have that expectation that you can't really learn this in a few days. You have to constantly, uh, consistently learn. Consistency is key. I know I'm preaching to the choir here. All of you have learned Salesforce. You have been consistent. And that's the same thing you have to do with programming. The challenge with moving too fast is that you sometimes move so fast that you miss the basics. And if you miss the basics, you're going to have a very hard time learning the next concept. And as an example, imagine trying to learn algebra without spending the time on basic arithmetic, without learning how addition, subtraction, and all these basic things work. If you miss those out, then of course trying to learn algebra is going to feel absolutely impossible. Right? So that's what we have to do. We have to um, spend the time to learn these things. And finally, practice. Practice is absolutely essential. If you remember, like, when I was studying mathematics, I remember that homework used to be so repetitive. We used to get like problems and just solve 10 of these, 10 of these, 20 of these. And it's just solving similar problems over and over. But this is extremely important because solving things over and over helps us internalize them. For an example, the pattern I shared with you earlier, like A is not equal to null and A dot name is not equal to null. You probably had to think about it a lot when you looked at it. But I can tell you people who are coding and people who are coding every day, it just comes naturally. We don't even think about it because it's internalized. Or looping over a list. For integer I equal to 0, I is less than array dot size, I plus plus. It's so internalized that we don't even think about it. But if you're doing it for the first time, of course, you'll think the array is indexed. We have to start at 0. We have to make sure we stop at 1 less than uh, the array length. It's difficult the first time you're doing it. But once you do it like 20 times, it becomes internalized. So a lot of coding is about picking up patterns and just reusing those patterns. So the more you practice, the better you're going to get at it. And how do you practice? One is the dev console. So just open the dev console, put things in there, use system.debug to try to figure out different things. And there's also apexsandbox.io. That's a website that me and Madiha, I think she's on the call as well, we put together to practice some basic Apex problems. And once you do that, once you practice some basic problems, harder problems start becoming easier. So that is why practice is key. You don't want this. You don't want yourself in a situation where you're looking at, that microwave touchscreen where nothing makes sense and the buttons are just blank. You want to be looking at the one on the right. If you see those buttons, then all the examples are going to make sense. So we'll move on, but there's one point I want to address, because when it comes to development, it's not just Apex. We're also talking about web development. We're talking about JavaScript, HTML, CSS, Lightning Web Components. Lightning Web Components are gaining a lot of traction. And before that, there's also Aura Components, there's Visual Force. So there's definitely a lot more components to it. HTML, I'd say the one place you can go and learn it is w3schools.com. It's been the best tutorial out there since forever. Uh, as long as I've been in the industry, well, since forever is the wrong term. Since I've been in the industry, I've seen that to be the simplest, the easiest to follow tutorial out there. It's hands-on, you get to practice. You can do it right now. You can do it after you learn Apex. You can do it while learning Apex. There's no right or wrong answer here. And the same for CSS. w3schools.com. You can go there, start learning it. And finally, there's JavaScript. You have to learn these three things before you learn LWC. But my recommendation would be to stay away from JavaScript for now. If you have not mastered Apex yet, or at least gained some degree of comfort with Apex yet, you shouldn't be looking at JavaScript. It's a little different. As a language, it's not in the same category as Java and Apex. So you don't want to overload yourself. But once you have learned Apex, then you can start studying JavaScript. And once you have learned JavaScript, that's when you get to Lightning Web Components, because they are built using HTML, CSS, and JavaScript and Apex. So for LWC, you need these four components first. Otherwise, LWC is going to be extremely overwhelming. Right, so with that out of the way, let's move on to a practice problem. And I want to demonstrate how you can practice, how you should practice writing code if you have a problem to solve. And I'm going to give you an example problem. Given three integers, return the largest. This is a practice problem that I have on the website, apexsandbox.io. So we are trying to find the largest of three integers. I'm going to go back to the presentation and show a flowchart of how we could solve this. So if you use Flow, you may be familiar with how the diagrams are for flowcharts. We start with this little circle start, and we are trying to build a repeatable recipe for solving this problem. So we have three variables. We have num1, num2, and num3. Which one of them is the largest? Now, this is the first part of my flowchart. So first question I would ask is num1 greater than num2? And if the answer to that is yes, num1 is greater than num2, then I'd ask, is num1 greater than num3? And think about this. If num1 is greater than num2, and num1 is also greater than num3, that's pretty clear. Then we have the answer. Num1 is the largest. But what if num1 is not greater than num2, or num1 is not greater than num3 if one of these conditions fails? What happens then? If one of these conditions fails, then that means we are left with num2 and num3. Num1 is definitely not the largest. So at that point, we just have to worry about num2 and num3. So we'll ask, is num2 greater than num3? If the answer to that is yes, then we pretty clearly know num2 is the largest. From the earlier conditions, we know num1 is not the largest. It has to be num2 or num3. And based on this check that we just did, is num2 greater than num3? Then num2 is the largest. And finally, if this one is false, if the answer to this question is no, then it means num3 is the largest. So this is the problem solved as a flowchart. We can put any values for num1, num2, and num3, and if we work this through this flowchart, we are going to get the answer. So I'm going to simplify this flowchart a little bit. I'm going to combine the first two conditions. We're asking two questions. Is num1 greater than num2? Is num1 greater than num3? So we could just combine them into a single condition. And this is what the flowchart would look like. We ask the question, num1 is greater than num2, and num2 is greater than num3. This is how you build conditions in Flow as well. You write multiple conditions, separate them by and. If you've been using Salesforce, you'll be familiar with this because this is how we put conditions in list views as well, and in many different places in Salesforce. So we ask the first question. If it's true, num1 is the largest. If this is false, we ask the next one. Num2 is greater than num3. If that is true, num2 is the largest. And if it's false, we say num3 is the largest. So this flowchart that I have here just translates so naturally to code. So if you read the code on the right, if num1 is greater than num2 and num1 is greater than num3, return num1. Else if the above was false, if num2 is greater than num3, if this one ends up true, then return num2. Else return num3. So this code over here is just pretty much a direct translation of this flowchart. And if you are writing code and you're struggling, you can't really get to it. Sometimes a really good thing to do is to take a step back and build a flowchart. Just write the algorithm, just write the solution as a flow, and then see if you can come back and write the code. So let's try this. The code that we have just written here, let's get into the website and let's see if this does the job for us. Given three integers, return the largest. So what we talked about is if num1 is greater than num2 and num1 is greater than num3. In this case, we return num1. We know that num1 is the largest. But if this condition is false, we know we are left with num2 and num3. So we can simply check if num2 is greater than num3. That means obviously num2 is the largest number at that point. And finally, if none of these conditions are met, the final result is going to be return num3. Let's try that. Let's write that out. Let's click the run button. Oh, there's some mistake here. I'm not sure which that is. Can anyone see where I made a mistake? Oh, I see it. It's supposed to be else if. Sorry about that. There we go. So as you can see, we went from a flowchart and we went down to code, and that made solving the problem far easier. Okay, so I'm going to do this one thing right now. All of you who are attending, if you have not registered, here's a link to register for the raffle. At the end of the session, I'm just going to run the raffle and see who gets the prize. So if you have not registered for it, just go to the link and register and we'll see who gets it. Oh, was it wrong on the slides? I think it was pretty much the same. So if I look at the code on the slide, it says if num1 is greater than num2, is num1 is greater than num3, then return num1. else if num2 is greater than num3, that means num2 is the largest, otherwise return num3. I think it's the same. That was a mistake I just made when typing out. Oh, I'm sorry about that. You're absolutely right. I have a mistake there on the slide. Let me correct that right away. It should be num1 is greater than num3. Thank you so much for catching that. Yeah, there it is. That's what the flowchart looks like after the correction. I'm sorry about that. And thank you so much, Mariano, for catching it. All right, so let's take a pause there. So that's the last slide I had for this presentation, and I'm going to leave the last 15 minutes to see if we have any questions. And if not, we're just going to run the raffle and see who gets the prize. So if anybody has any questions, feel free to drop them in the chat. Feel free to request microphone access. I'm not sure if I can give everybody microphone access by default. But if you ask, I think I'll get the option. So I've opened up the session for Q&A. You can see the Q&A tab as well. If anybody has questions, feel free to drop them in there. I'll just wait for a few minutes to see if anybody has questions. And if not, we'll just run the raffle. Okay, so one question Prasant has is, are there any good resources for object-oriented programming concepts? So I would say the book I shared there, the book that's called Java, A Beginner's Guide by Herbert Schild. I think that's a very good resource for object-oriented programming. Java is one of the languages that is known for, popularizing a lot of object-oriented programming concepts that we use today. And that book will do a good job of introducing you to it. Other than that, I'm thinking of what other good resources there are. You can follow some YouTubers as well. I know there's some people putting out really good videos out there around like object-oriented programming concepts. Bruce Johnson is one of them. Matt, Jerry, or Gary, I don't know how you pronounce his name. He's one of them. You can follow their channels as well. They're fantastic. So I'll put these answers in the chat as well. And there may be a lot more resources that I'm not fully familiar with. So if anybody in the chat knows, other resources, feel free to drop those ideas as well. Head First Java. So that's actually a really good book as well. I think David Liu actually recommends it in his course as well. So yeah, definitely that one too. Thanks for sharing that. Head First Java. I would put that in the reply as well. Share that last slide. So thank you so much for coming to my session. And I'd you. So if you are seeing this, definitely connect with me on Twitter. And generally, if you have any questions at all, if you'd love to chat about something, I'm more than happy to set up time to talk as well. And I'd be looking forward to hearing from you. Thank you so much. Thank you, Marlene. And you're welcome. Thank you, Yashoda. I'm glad you liked it. You're welcome, Mariana. And thanks for all the contribution there and for correcting me where I messed up.